Hey, welcome everyone. Good evening. I'm Joe Krobeck, software engineer. I work at Foursquare, and I'm going to be talking about some experiences we've had running Hadoop in the cloud, in Amazon Web Services, and the process of migrating to the data center. So, to give you a little background on Foursquare, just so in case anyone's unfamiliar, Foursquare is a recommendation engine for local personalized, that generates local personalized recommendations of venues, coffee shops, restaurants for users to visit. And a user can then go to one of these venues and check in or leave a tip or bookmark a venue. And in addition, we have a third-party API that is used by a lot of applications. So we generate a lot of data. We have over 35 million people on Foursquare, 50 million places, and over 4 billion check-ins. In terms of data volume, this gives you a picture of one of our log collections and how much data we're ingesting. It's about 2.5 terabytes per week after compression, and it's growing at a pretty, our data sets are growing at a pretty fast rate. We use Hadoop for a lot of features. This slide here is a picture of our venue page on our website. And I've kind of highlighted some of the features that are computed offline via MapReduce. Things like similar venues to Tal Bagels, people that go here, go there, and a venue rating of how good the venue is. We also do a lot of ad hoc analysis with Hive. We power dashboards with datasets built from MapReduce. And we have a lot of people using our Hadoop infrastructure. I did a search, and it looks like about half of our engineers / data scientists have written a MapReduce job, and hundreds of people in the company, well, not hundreds, I should say 100 people in the company have used Hive, and dozens of folks have run over 100 Hive queries. So what I'm trying to get across by all this is we are a very data-driven culture. We have a lot of people using Hive and MapReduce. The team I'm on is 3 folks, and we are supported by other teams. We have some people working on APIs with us. We have some people from our site reliability team helping us build infrastructure. But we do basically, we own the stack end to end, from deployment to applications. We aren't writing MapReduce jobs to power features, but we are writing MapReduce jobs to power internal analytics. And these are some of the areas that we own inside the company. Okay, so with the background kind of out of the way, I want to go through the history of Hadoop at Foursquare, at least since I joined the company about 1.5 years ago. When I joined, Foursquare was entirely in Amazon Web Services. We had started generating data via application logging with Flume and storing it in S3 for offline MapReduce. And we were also dumping our production databases through what we called a Mongo export process to store data in S3, but these were incremental dumps at the time, not a full copy of the database every day. Kind of the motivation, or the way we got started was that everyone in Amazon knows that spinning up a EMR cluster is a breeze. You basically execute one command and you now have a 10-node, 50-node Hadoop cluster. And it turns out that, at least in my experience, the APIs around Elastic MapReduce are really optimized for a short-lived cluster. Or put another way, you are expected to spin up a cluster per workflow or per job that you have. It's not really a multi-tenant environment. even though we wanted it to be. So we had kind of taken EMR, Elastic MapReduce, and bypassed all the APIs that Amazon exposes and started submitting jobs directly to the job tracker or Hive and enabling the fair scheduler so that we could have multi-tenant queries running on the cluster. And Amazon EMR has the ability to customize your cluster. So you can run these bootstrap scripts, and you can do lots of things, which we did. We installed packages, we set up configuration to enable the fair scheduler, all these types of things that you normally would do with some sort of configuration management system. And it's really easy to get started, but it gets complex if you need to change a configuration. Iterating on these bootstrap scripts is kind of slow. And also, if you're just running your cluster all the time, you're not really taking advantage of the elasticity of EMR. So you're kind of paying an overhead of running EMR, but not getting the benefits, which is what we were doing. And finally, the one thing that's kind of tricky about EMR is it's not great to integrate into open source workflow engines like Oozie or Azkaban. It's powered by an API that Amazon exposes, but it's not super easy to, say, run a Hadoop job and then have your workflow engine run the Hadoop job and then take the data and import it into a database. Sorry, it looks like I lost the titles to my slides, but basically lesson learned with EMR was that the Hive server version 1, this is well acknowledged, and Hive server has been rewritten, but it was really buggy, and this was a common source of pain because we didn't realize just how buggy it was. And I'll get into so those some of the motivations, and I'll get into them a little bit more about why we wanted to move from Elastic MapReduce to a persistent cluster in EC2 running CDH. So it turned out that one day we went to spin up a new cluster and the bootstrap script failed. Basically what happened was the Elastic MapReduce AMI, this is like the image that your server starts with when it's booted up, was using such an old version of Debian that the package mirrors that we were installing software from actually were turned off. And we couldn't install any of the packages. And the only option was to upgrade to a new version of the EMR AMI, but that was an entirely different version of Hadoop, an entirely different version of Hive. And we weren't ready to kind of make that major jump while staying on EMR. So we had a proof of concept cluster at the time running CDH, and we just kind of grew it and said, all right, we're gonna accelerate our move. So this was about a year ago, and when we were deciding to set up our cluster, we said, all right, do we want to run HDFS in Amazon? And at the time, there wasn't this HS1 instance, which is actually a really attractive instance to run HDFS in Amazon. But even still, if you are running HDFS, you have to worry about capacity. With S3, you have infinite capacity, or nearly infinite capacity for storing your data, and you don't have to worry about ever running out. So basically, we decided to run a small HDFS in the cloud and use S3 as our main storage point. And we decided to use basically the beefiest, fastest machine that Amazon had at the time, which is the CC2 8x large. And what we found was that we were running a lot of Hive queries. And if you have a Hive query, you have potentially many MapReduce phases in the entire job. And each phase might have some stragglers where one reducer is taking longer than the rest. And throughout the entire MapReduce flow, those stragglers add up really quickly. So we instead of using 100 of some smaller instance, when we moved to the really fast instances where the stragglers finished more quickly, it had kind of a multiple or an additive effect throughout the subsequent MapReduce jobs. So we ran these bigger instances because it really made a difference. With that said, there were definitely some drawbacks in running vanilla Hadoop or CDH instead of Amazon ZMR. The number one feature it's missing is multi-part uploads to S3. And I'm hoping there are some Hadoop committers in the room because there's a patch open to add S3 multi-part upload support. And it's just kind of been sitting there. So we'd love to get that in. I didn't work on it. It just looks like someone's contributing it. There's some other features like Hive had this recover partition feature, which was eventually added in Hive 11. You're still on virtualized hardware, even though these CC28X large instances are dedicated. They're not really dedicated. You're still running inside of a hypervisor. You see things like all of your network interrupts come in on a single core, and it can be really difficult to measure what the bottleneck is because you don't have the actual instance. So we would see strange things like high system CPU, but we couldn't figure out what the cause was. Not super high, but high enough to be annoying. There's a couple other lessons we learned. So when we first spun up our cluster, these instances we were using have 10 gig E, and we didn't really pay attention to which availability zone we put them in. And it turns out if you put them in the same availability zone, it's a lot faster. So maybe someone else, I'm hoping to save someone out there in the crowd some time. We got pretty drastic performance improvements once we put all of our nodes in the same availability zone. We also had some issues with S3. We're using the US standard region, and your data is actually replicated on both the east and the west coast, and we would sometimes have straggler map tasks that were taking 10 times longer than all the other map tasks in the job. And it turned out that our bucket was so old, generated so long ago, that it wasn't properly homed to the correct coast, and we were actually MapReducing on data in the west coast. So once we got that fixed, that was another set of pretty drastic improvements. S3 is great because it's infinite, but it's also pretty fickle, and you don't have the ability to debug it when it goes wrong. We've seen some really strange things with 500s and directory listings. I say directory listings in quotes because Amazon doesn't really have or S3 doesn't have directories. But so you have this trade-off of like this infinite storage versus a few headaches, and for the most part, the headaches don't get in the way until they really do. Something we learned along the way that was super helpful, when we first started running our cluster, we would probably have data loss on a weekly basis in our ingestion pipeline. And along the way, we moved from Flume to Kafka. This is the old generation of Flume to Kafka. But I think what really saved us in terms of data loss was not having our ingestion process write directly to S3. Instead, we started writing data first to our small HDFS that could buffer something like 7 days worth of data. And then we would do our ETL process where we squashed files down and transformed them to sequence files or what have you inside of data in HDFS and then place that to S3. So if S3 was acting up for the day, we could just redo our import from HDFS to S3. And actually, we've done this twice in the past week. We've had a couple of issues. Whereas our old architecture of just writing directly to S3, we would have lost all that, hours, days worth of data. One of my war stories, that was in the description, if you saw it, how to resize HDFS in a weekend. So basically we had n nodes, let's say 10 nodes, and they had certain number of EBS a certain amount of EBS volumes attached, and we essentially doubled the cluster for the weekend, and the new nodes came up with twice the EBS capacity, decommissioned the old ones, come in on Monday morning, and you can shut down the nodes with smaller capacity, and now your HDFS is twice as big. This is like truly the power of the cloud, right? You don't have to wait 3 months to provision new hardware. You just spin up twice as many and move everything over. Some other lesson learned. We invested in configuration management, but it turned out we didn't quite do it as generally as we should have. So we had to spend a lot more time when we actually started moving to the data center to make our configuration management more general. So this is something to keep an eye on from the beginning. And I've also found that the management software is super useful. We're using Cloudera Manager, but Embari also looks super great. The less you're SSHing to machines, I think the better. And you have many services running on your cluster, and coordinating restarts between MapReduce and HDFS and Hive and whatever else can be a lot of problems, whereas that logic is all encoded in your management software. Another huge thing, we had started out running our own MySQL databases for the Hive Metastore, and we recently switched to Amazon RDS, and I can't say enough good stuff about it for your MySQL Metastore, your Uzi data store, your management software data store. We actually ran out of capacity, storage space on our RDS instance more than once, and you just issue a command line program call to the RDS instance, and all of a sudden it takes about 10 minutes and your RDS instance is doubled in size or whatever you want. And it's fully replicated between availability zones. It's just something, who wants to run a Hadoop cluster and manage MySQL, make sure it's highly available? You just kind of offload that to Amazon. And I think we're going to continue to run RDS after our data center move. Another big thing, I won't go into this too much, you can do the calculations for yourself, but you want to do reserved instances. If you're using on-demand instances, it gets expensive really, really fast. Can sometimes be hard to know if you're going to be in the cloud for 3 years, but a 1-year reservation gets you most of the way there. Okay, so to the data center and beyond. Talking about some motivations for moving to the data center. I think the first one is definitely cost. I looked at a couple different ways to store your data, and these are sort of back of the envelope computations, but if you look at EBS here, I said you can store it with replication equals 2 because EBS is already redundant, or your beefy data node instances in Amazon, or even using S3, you're going to pay these costs per year, whereas if you run your own cluster, you're going to pay an upfront cost once, which is, in our case, even less than all the other options that are available inside of Amazon. So this is just, this is not like the cost of hard drives. This is looking at buying a rack and total cost in, how much per terabyte did we spend. Second motivation is definitely performance. Our first rack outside of Amazon cost about the same as running our 15-node cluster in EC2. And while we don't have 10 gig Ethernet and we don't have the faster processors, we have a ton more cores and slots on our machines. And I alluded to this before. There are some reasons Hadoop-specific reasons to get out of the cloud. Number one being that Hadoop and S3 kind of work, but don't really in some cases. They're drastically different semantics. Hadoop expects a rename to be instant, whereas if you're doing that in S3, you're actually copying a file to a new location and deleting the old one, so that obviously takes some time. And a file close in S3 is a file close in HDFS is instantaneous, but in S3 you're actually, when you close the file, that's when you start the upload. So if you have a 5 gig file, Hadoop's expecting it to close and be instantaneous, but it takes 10 minutes to upload your 5 gig file to S3, then really confuses the MapReduce framework. The other main point, all of our other systems were moving to the colo, so it made sense for us to move Hadoop as well. Definitely some trade-offs. I'll expand on some of these. HDFS is capped, so when we originally planned out our Hadoop cluster, it took us a long time to procure the hardware, but by the time we got it, we were like, well, if we put all of our data in our Hadoop cluster, we could fill it up. So by the time we got our first rack, we were like already buying our second one. And that stuff takes time. Whereas like S3, you just like dump data there and it's infinite. We also went through this, well, we're still going through this awful process of importing our data from S3 to HDFS. You don't have an infinite pipe anymore between your services and S3. So, and in our case, we're actually sharing our pipe with production services that power Foursquare.com, power our iPhone app, our Android app. And because of the network structure, you can't QoS the data coming out of AWS. So you have to be really careful that you don't stomp on your production traffic. You have to worry about offsite backups as well. What we're doing is we're putting data in S3 as a second, as a backup. And that works really well with Kafka because you can have multiple consumers of your data, and we'll have one right to S3 and one to our colo HDFS. This is something that we lost a lot of time with. I don't think we did it on purpose one way or the other, but when we ordered our rack for the first time, we got consumer grade hard drives, and we actually swapped out 40 disks and saw the exact same performance that we saw the first time around. And maybe this isn't true for all consumer disks, but it was definitely true for the ones that we bought. Basically, some disks would run at 10 megabytes per second. Some would run at 150. And there was so much variance that MapReduce would start to have these cascading failures that would fail the simplest of jobs. As it was writing data out, a data node would time out, and then that would bubble up and whatnot. So this is the lessons learned for data import slide, since you guys can't see the title. This is true story. First time I copied data from S3 to HDFS, I saturated our pipe and nearly took down the website. You have to work really hard, monitor everything. -M limits the parallelism in DisCP. Size limit lets you say, all right, stop after you copy 10 gigabytes so you don't have to babysit things. And we found that DisCP works really well when you're reading from S3, but it doesn't work really well when you're copying to S3. And it's related to the file system semantics that I mentioned earlier. And I highly recommend DisCP v2, which I use this backport for CDH4. But I believe it's part of Hadoop 2.0. So, conclusions. If you're in AWS, then Elastic MapReduce is a great service to start with. I think everyone should start that way. It's just so much more productive, and you'll get to a certain point where you're running so many jobs, your cluster is always running, you want low latency, that you need a persistent cluster. And a persistent cluster in the cloud is super convenient in terms of things like resizing, provisioning new hardware, well, new instances. But at some point you'll get to the you'll get to the point where cost and performance in the data center will provide such a significant incentive that it makes more sense to be in the data center than it is to be in the cloud. So that's it. I can take some questions if there are any. We have 2 microphones in the aisles out there.
Hi. First, my compliments. This is by far the best talk of the entire conference that I've heard.
Thank you.
And I would like to know if you'd consider making these slides available.
Yeah, that shouldn't be a problem.
Okay, I'll be in touch.
Well, oh, here we go, one more.
Yeah, just we had a very similar situation, so just wanted to couldn't agree more. We started with EC2 just like any other startup, and then we moved down to our own colos for more control over things, and just couldn't agree more with the S3 brownouts. Very similar observations. Then we had some upstream connectivity issues with EC2 itself, and especially the one where you talked about the disk CP between S3 and the local HDFS and saturating out the network. We had a very similar issue, so just couldn't agree more. It's a great talk.
Thanks.
So, so you had a lot of MapReduce jobs already inside of EMR.
Yes, at one point.
So when you were moving them from EMR to CDH on EC2 or in the data center, did they just move, or did you have to rewrite a lot of things?
So there was a mix. We actually, in EMR, were running a lot of Ruby streaming jobs, and we decided we no longer wanted to do that. So those we all rewrote in Scala MapReduce. So Scala is a JVM language that we use at Foursquare. Hive jobs, pretty much we could just take them as is and move them over. And we also kind of restructured the code base around the same time. So there was a lot, yes and no, I guess is the full answer.
Can you elaborate a little bit on the numbers that you had on hardware, like buying hardware in your own colo, and the numbers per terabyte? Like, what all factors did you consider there? Can you elaborate a little bit on that?
Sure. So basically, I looked at, we got a couple different quotes for costs of racks, depending on processor speed, types of drives, and I basically just looked at, hey, if we need to store 3 copies of the data in HDFS in the colo, how much does it cost? If I store 1 copy of data in S3 because there's redundancy, how much does it cost? And I think the price per gigabyte came out to around 800, or the price per terabyte came out to about $800 in the colo. And that's like the total terabytes in the rack divided by the full cost of the rack, including networking and everything.
Do you have a sense for how much, just a back of the envelope kind of calculation, how much you guys saved when moving over from AWS to the colo, or how much you got in terms of throughput?
So the why of this conversation, presentation is we haven't completed our migration yet. We're still in process. But the back of the envelope estimate is that a year of operating EC2 is the upfront cost of our cluster. So after that first year, we're just paying our OpEx of power and colo space, which is much less than it would be to run inside of EC2. So it's pretty significant savings.
Thanks.
We are, when you do the cost analysis, AWS versus colo, have you factorized the on-site operation cost?
No, that's a good point. I haven't. There are definitely more costs associated. But since the AWS costs are recurring and the costs that I estimated are one time, I kind of figure it washes out a little bit. It's not exact. It's not the exact computation. I haven't had the time yet to factor in all the costs associated with it. All right, thanks everyone.